Okay, good afternoon, class. We're going to finish our discussion on systems of equations, matrices, determinants, and Cramer's rule by looking at some word problems here. I think we're ready to pick up with number 15. And could you dim the lights, Tony?
Okay. I think that I would suggest, I think you're going to use probably elimination.
Probably.
On all of these.
A basketball player scored 25 times during one game. She scored a total of 39 points, 2 for each 2-point shot, and she got 1 point for each free throw. How many 2-point shots did she make, and how many free throws? So this is number 15. And, okay. She scored 25 times. I'm just writing down, I'm sketching out the important information. She scored 25 times. I am probably
Move it up, maybe.
Is it still falling in and out?
No, but okay.
Scored 25 times during one game. She scored a total of 39 points. I'm just writing down the important, what I think is important. And she got 2 points for each 2-point throw. That makes sense. She got 2 points for each 2-point throw. And she got 1 point for each free throw. I think that's standard, isn't it? And the question is, how many 2-point throws did she make and how many free throws? So, how many 2-point throws? Can you switch over to? And how many free throws? Well, I think there are 2 unknowns here. There are 2 things we don't know. It's the things they're asking us. The question helps you decide what the unknowns are. How many 2-point throws did this basketball player make? How many free throws did she make? Those are my 2 unknowns. So, I'm going to write a system of equations if I can. I'm going to let X denote the number of 2-point throws. I should have started on the top of a sheet of paper. Number of 2-point throws. What do you think I'm going to let Y be? The number of free throws. How many free throws did she score?
Maybe you should move to a new sheet of paper.
I'm going to.
I mean, right now.
So I'll let. I'm going to let X be the number of 2-point throws and Y be the number of free throws. And Y is the number of free throws. Here's something you're going to want to remember when working with systems of equations. If you want a unique solution, then you should have, your general rule should be the number of equations, the number of distinct equations should equal the number of unknowns. We have 2 variables, so we should try to find 2 distinct equations. Switch back to my lab. The player scored 25 times during one game. I think that's given us 1 equation right off. She scored X 2-point throws and Y free throws. If you add those 2 together, they should equal the number of times she scored. X plus Y is equal to 25. Any questions on my logic there? That's just a result of the fact they told us she scored 25 times. So if you take the number of 2-point throws she made plus the number of 1-point throws, that should equal 25 throws. She had a really good game that day. Now we need another equation. We need another unique equation involving X and Y. Let's go back to what they said. She scored a total of 39 points. Okay. That sounds like a total to me. So it sounds like we need to have an equals 39. So our second equation, I think, should equal 39. Let's figure out how many points did she get from the 2-point throws. She scored X throws at 2 points each. Suppose she had thrown 10 2-point throws. What's the total number of points she got from those 10 2-point throws? 20. You go the number of points per throw times the number of throws. So 2 times X. That's the number of points she scored from the 2-point throws. That 2X, I'm going to write that down. That's the points scored from her 2-point throws. Okay. How many points did she get from the free throws? They tell us that the free throws are worth how many points? Just 1 point. So 1 point per throw times the number of throws. In terms of Y, how many points did she get from those free throws? Here we went 2 points times the number of throws to give us 2X. What will we do in terms of Y? 1 point times the number of throws Y. So there. This is the point scored from the 2-point throws. What is that Y? That's the points from the free throws. If you take the points she got from the 2-point throws, add it to the points she got from the free throws, they better give us 39. Any questions on my logic there? I think I'm going to recopy that system right now without all the little parenthetical remarks that I made there. So it's X plus Y equals 25. And the other one is 2X plus Y is equal to 39. We could use either elimination or substitution. I suppose we could use Kramer's rule, but that seems like using a chainsaw to cut butter. I think elimination or substitution would be the easiest. I noticed something. The Y variables, what are their coefficients?
They're both 1.
Both positive 1. I'm going to change this first Y to have a coefficient of negative 1 by multiplying the first equation through by negative 1. So that new equation becomes negative 1x minus 1y equals
negative 25. So then we can subtract that to 2x plus y equals 39. So that we can get x equals 14.
Okay, so we're adding the two together. Notice we have the same coefficient but opposite signs on the y. Negative 1x plus 2x. I agree, that's just going to give us a plain x.
So negative y and positive y cancel each other out.
So you've eliminated the y. That's the name of this method, elimination. We've just eliminated the y.
Down the equals sign, and negative 25 plus 39 equals positive to 14. So x equals 14.
So 14 is what? The 2-point throws. So she scored 14 2-point throws.
Let's see, is that what they
I think that's the first
define?
question.
Okay.
She made 14 2-point throws. Well, how many free throws did we get, or did she make? How can we figure that out?
I think it might be easiest to do the first one.
I think so too, that
So
x plus y equals 25.
So it would, because we know that x equals 14, we can just separate the x. So it's 14 plus y equals 25.
Wait a minute.
X equals.
X equals
Yeah,
14.
we just gave the answer.
I know.
That y equals to 11. But let's continue on. Minus 14 from both sides, so we get y equals 11.
That's right. Yeah.
You actually put x equals 11, spoiling the answer.
Yes, I did. You're right. Did y'all follow that over there? Once we knew x was 14, the easiest equation to plug it into was that x plus y equals 25. Or you could just stop and think. You knew she scored 25 times. 14 of them were 2 points, so how many are left? The other 11 scores had to be free throws. Any questions there?
Let me put it back here.
Any questions there? This was what number?
That was number
Number 15, yes. Oh, I should have known that. I forgot to turn this thing off. Any questions? Earlier I made the remark that, however, if you have two variables, you should expect to have two unique equations. By unique, I mean you can't just take the first one, x plus y equals 25, and maybe my second one I just multiply 3 by 2 to get 2x plus 2y equals 50. Those aren't unique equations. You have to use the information to come up with two separate equations.
Next one.
Okay. This is number 16. A woman bought some large frames for $16 each and some small frames for $7 each at a closeout sale. If she bought 18 frames for $171, how many of each type? Find how many of each type she bought. What do they mean, frames?
I think it's picture
Glass
frame.
picture frame?
Okay.
Okay,
Yeah,
that makes sense. Picture frames. I was thinking glass frames. I was like, that's weird. Okay.
Well, monocles, apparently, then. If they're framed for glasses, they would just be monocles.
Okay, so let's. I think I'm gonna summarize this information on a table right now. Okay. Maybe I should have used a table on the first one. I like to use tables if I'm setting up information in a business math class. So let's try summarizing this. There are two things we don't know just from reading the question. There are two things we don't know. What are they?
What's x and what's y?
Well, yeah, you're right. Okay, and what are those variables going to be? How many large frames did you buy? How many small frames did you buy? So I'm going to go switch over. I'm going to summarize the information. I'm going to try to summarize with a table. Large frames and small frames. And we don't know how many large frames she bought, so we'll just say X. And we don't know how many small frames she bought. I bet you're right. These are picture frames, okay? She's buying picture frames. And so we'll say Y for the number of small frames. Let's switch back. When I'm working these problems, I go back and reread the problem over and over. I get a little piece of information, and then I go back and I write it down on my paper. Then I go back and I read more, okay? The large frames cost $16 each, and the small frames cost $7 each. So I'm going to write a little, I'm making the little table, and I'm going to say that X and Y are my quantities. She bought X large frames, Y small frames. And the cost. We know how much each of those frames cost. The large frames cost, what did they say, $16? The small frames were $7. Let's keep on reading. Look at that second sentence. If she bought 18 frames for $171, how many of each type? Find how many of each type she bought. So she bought 18 frames. Switch over to my paper. Okay. So if she bought X large frames and Y small frames, if we were to total those, what would that total have to be? I'm going to add them up.
171.
No. How many frames did you buy? Switch back.
Oh, 18.
She bought 18 frames. So if you total the quantities, it would be 18. So there's the first equation. X plus Y is equal to 18. Any questions on my logic there? Notice how I keep going back, rereading the problem. I go back, looking at it, taking more information. One thing that stood out to me is that if you add the number of large and the number of small, you're going to get 18 frames. Now the cost. What did they say about the cost?
It equals to 171.
So if we totaled the cost of all of these frames, it would cost $171. I'm totaling the cost column, and it's going to give me $171. How much money did this woman spend buying large picture frames? Suppose she had bought 10 large picture frames. How much money did she spend?
160.
You take the cost per item times the number of items. You take the cost times the number of items. That tells you how much you spent on large picture frames. So 16x. Cost per item times the number of items plus. How much money did this lady spend buying the Y small frames? Every frame was $7. Apply the
7Y.
Okay, the cost per item times the number of items. 16x. That's all the money she spent buying those large frames. 7y. That's the money she spent buying all of those small picture frames. If you take the money she spent on the large frames plus the money she spent on the small frames, that had better add up to $171. Any questions on my logic there? Well, I think once again this is a good problem for elimination. Remember, I prefer elimination over substitution. I could solve for x or y here and use substitution, but I think I'd rather use elimination. Which variable do you think I'm going to eliminate? Which one am I going to try to get the same coefficient but opposite sign? I could change this x right here, this 1x, to a negative 16x, but I have to multiply by negative 16. I think I'm going to multiply by the smaller number. 7. I'm going to change that y coefficient there to negative 7 by multiplying through by negative 7. So that first equation is going to become negative 7x minus 7y equals a negative 126. I tell you, my mental arithmetic.
70 and 56. Yeah.
Mm-hmm.
Okay.
And then we have the second one. Wait a minute. Let me write the second one right here. 16x plus 7y. That is a 171. I'm just recopying the second equation. I'm adding the two equations together.
So it would be
Negative 7x plus 16x. That's a 9x.
9x.
What?
The y's cancel each other out, so it's just equals to 45.
So the y's have been eliminated. I like to use that word eliminated because that's the name of this method we're using. And then we have a negative 126 plus 75. That's going to give me a positive 45. I agree.
And we divide both sides by 9 to get x equals 5.
So 9x equals 45. Divide by 9 to give us x equals 5. Is that $5?
$5.
No.
5 on large frames.
Okay, so this woman bought.
Answer column.
Okay, I'll put an answer column here. I like that. We'll put, she bought 5 large frames.
And because we already know that she bought 5 large frames, we can subtract 5 from the total of 18 to say that she bought 13 small frames.
That's
Right.
I mean, you can just think your way through it. 5 plus what gives you 18? 18 minus 5 gives you 13. So she bought 13 small frames. Or you could just go through substituting.
I like the logic better.
Okay, so you have 5 plus y equals 18. Subtract 5. Either way, we get y equals 13.
You know, Tim, we should mention something. For
Should
future
we?
people watching this, there's 2 of us that sound alike.
Really?
So
Or
the people watching this video in the future or overseas, they're going to wonder, what the heck? Why does he it sounds like he's talking to himself.
I like
There's
it better
2
if
of
they
us.
think that it's a split personality, that there's someone up here with a split personality talking back and forth to himself. I think that would make the videos actually a little funnier, don't you think?
Well, it would be even funnier if I also sounded like you guys. So it just sounded
Yeah.
like
Yes,
3
that
of the
3
same
people with one person with 3 split with multiple
Okay.
personalities.
I was being serious, but anyway, let's type in our answer.
But there is a distinct difference between your 2 voices.
Well,
Yeah, one's more higher pitched than the other one.
okay.
Really?
Yeah, it's just slightly.
Our family can't tell us apart on the telephone.
I can't, like, if
5
you
and
just
13.
showed me you 2 and tell me, like, oh, who's, tell me who's, I forgot the other name, sorry. I won't be able to differentiate, but if you guys started talking and I was like, okay, this person sounds like, tell me this other person sounds like the other one.
Any questions here? Okay, any questions on this one?
I'm not talking much because I have a sore throat, so I have my mask on, like always. I don't know how I got a sore throat.
I'll
but
tell you how, because we've been making all these separate videos, talking non-stop.
talking.
That's the thing.
Well, if it's just talking too much and that's why I have a sore throat, then great. I hate the thought of having a cold or something.
Well, you can't, because surely I would have it. I'm the one that has no immune system, so if you catch something, I'm going to catch it. Okay, number 17.
I think you should make another table for this one.
I'm
like the
going
way
to.
you did it.
The cost to attend a movie is $10 for adults, while children are admitted for $7. If a movie was attended by 58 people who paid a total of $451, how many adults and how many children attended the movie? I think this is something that we can summarize using a table pretty nicely. switch over to where I'm writing.
But what are they?
No, the first thing I think, wait, go back to it. I guess you're right. How many adults and how many children? Those are the unknown quantities. How many adults attended that movie and how many children? So I'm going to say, switch it to my adults and children. And those are the unknowns, the quantities. I guess I don't know why I'm using quantities. I could just say how many and label them X and Y. X adults attended the movie. Y children attended the movie.
And we know that the grand total of people who attended was 58.
Let's go back to that and see. The number of people who attended were 58. So that does sound like a total to me. So if you added X adults and Y children, that had better be a total of 58 people at that movie theater. They gave us more information. I think they gave us the costs.
Yes, they did. 10 for adults, 7 for kids, with a grand total of 45.
So the adult tickets cost $10. The children tickets cost $7.
Grand total of 451.
451. Look back at the problem. Let's make sure of that.
Yeah, that's right.
Yep. They paid a total of $451. So if you add up the total amount paid, it had better be $451. There are two distinct variables here, so we need two distinct equations.
I do kind of want to quickly kind of say that in a way you could try to make this problem possibly a bit easier by first just multiplying it 7 by things that you know will end in a 1, and then afterwards see if you can multiply 10 or divide by 10 by the remaining.
So you're saying trial and error. That's what you're saying, right? You're saying you just think your way through it,
and that would be great.
And that would be acceptable. That would be, you could do that, but we're setting up a system of equations, okay? Give me one equation. Let's have an equation involving the quantities.
X plus Y equals 58.
Okay, so there were X adults and Y children, so if you add them up, it better equal the number of people that were in that theater. 58 tickets were sold. Now, how much money did the adults pay? How much of the $451 came from adults? You take the cost per ticket sold times the number of tickets sold. Cost times quantity. So that's 10 times X. You tell me how many adults attended, I'll tell you how much money they paid. Cost times quantity for adults. Now you tell me how much money was taken in from the children ticket sales. Here's all the money from the adults. Okay, it's the cost per ticket times the number of tickets.
Plus 7Y equals 451.
Correct. Elimination or substitution? Substitution? Really? Okay. I was going to use elimination, but that's my favorite method, but I'm going to let y'all choose. Although I should confess, when I let friends choose where we're going to go to lunch or dinner, I let them choose, and if they choose the wrong place, you know what?
You let them choose
I let
again.
them choose again. They can keep choosing until they choose the right place. But we haven't done a substitution today, so let's use substitution. I noticed something. It'd be easy to solve for that first X that's sitting there. It'd be easy to solve for that first X. Let's get this X by itself by doing what? Okay, moving that y over, so we have 58 minus y. And then we're gonna do what the title says, substitute. We're gonna take that 58 minus y and substitute it in to the second equation. So we have 10 times 58 minus y.
Then we do plus 7y equals 451. Then we FOIL it out of 10 times 58 is 580.
Okay, so we're not really foiling, we're distributing. 10 times 58, I agree, is 580.
Then we do 10 times negative y, which equals negative 10y, plus 7y equals 451.
Okay.
Then we just then we add 7y to negative 10y, so it will be 580 minus 3y equals 451.
Okay, negative 10y plus 7y. I agree, that's a negative 3y. Now that we have the y's by itself, what do we need to do? Oh, no. Now that we've combined the y's, what do we need to do? I think I answered the question.
Minus 580 on both sides.
We got to get the y term by itself, so we'll minus 580. So we have a negative 3y is equal to, is that a negative 139? No, 129? 451 minus 580 gives me a negative 129, and then
We divide by negative 3.
divide by negative 3.
If we wound up with a decimal or fraction as our answer, do you think that that'd be right? I think if we wind up with a decimal or fraction, we're going to messed up.
Suppose we wind up with a negative number. You think that's sensible? Could they sell a negative number of adult tickets? You think that's possible?
I think for these word problems, you better expect positive integers as answers.
In other words, counting numbers. So
y equals
43.
So that means there was 43 kids at the thing. So we can just 43 minus 58, which that would equal to 15.
I like the way Tony said to put an answer column here in our little table. There were 43. Y is the number of children, and there were 43 children tickets sold. And remember, there had to be a total of 58 tickets sold. So how many adults were sold?
15.
Right here, we can take that 43. X equals 58 minus 43. Sure enough, that's 15 adult tickets. Any questions there? Here's what I was going to do. I was going to use elimination. To eliminate x, I would have needed a negative 10 here, so I would have multiplied through by a negative 10. I would have still gotten the same answer, though.
Or you could have done like the previous problem, and I think it was multiplied through by negative 7.
Yeah,
It
but
would
you
have looked
see,
a lot like this. This makes a point of why I think we prefer elimination, you and I, Tim. What looks cleaner? This or that? I think I like the elimination better. But it's good to see both today.
yes.
And I've got to get those answers to type them in. What were the answers on number 17? 15 adult, 43 children. So 15 adult, 43 children.
Any questions there?
Any questions?
Well, just How many times do I go back and read the question, picking out the little pieces of pertinent information, and you have to find a way to summarize it. You don't have to make a table, but it seems like it's an easy way. To me, it seems like the best way to summarize the pertinent information.
If you take Math 1324, Math for Business,
oh yes,
you might have a whole lot of unknowns, not just adults and children.
In Math 1324, you'll have something called linear programming. There'll be 4 unknowns, and you'll be trying to summarize all the information. At that point, when you have a large number of variables, you definitely need to summarize somehow orderly, and the best way, in my opinion, is using a table.
Are we ready for the next one? Everyone caught up? Any questions?
Okay, number 18.
Oh, wow, this is the last one, so it's got to be the hardest. Ignore this, use a Gaussian elimination or Gauss-Jordan elimination. Just do plain old elimination or substitution.
We could use Kramer's rule if we wanted to, but I doubt we want to. Mike works a total of 60 hours per week at his 2 jobs.
Oh, wow, this is a bad state of affairs. Someone working 60 hours a week.
He makes $8 per hour at job A and $9 per hour at job B. This is a depressing problem, Tony. Why did you choose this problem?
I think that the video that I have working these word problems another time, it was $7 and $5. So at least he's got a bit of a raise.
So he's working a total of 60 hours per week at his 2 jobs. He makes $8 per hour at job A and $9 per hour at job B. If his total pay for 1 week is $501 before taxes, then how many hours does he work at each job?
I just want to say, you guys are saying it's depressing, but that's like basic minimum wage now.
I know,
Yeah.
but having to work 60 hours a week at 2 different jobs.
It'd be better to work 60 hours at one job so you can get some overtime, right? But
some jobs won't really.
you're right. But if it were one that would pay overtime. So let's see. Mike is working. He's working at 2 jobs. How many hours does he work at each job? That last question there, that's telling you what you're looking for. The way they have that sentence, he works blank hours at job A and blank hours at job B, that's got to be the unknowns. So switch to my paper, Tony.
And you're going to make a table similar to what we've been doing.
Job A and job B. I'll say number of hours. We'll say he works X hours at job A and Y hours at job B. Okay.
So getting the hang of these, what's that next column going to be?
What do you think we're going to use for the next column? We know the number of hours. Maybe it's the pay per hour. This is making me want to do some linear programming, Tony.
Yeah.
Making
Another
these tables.
course.
Pay per hour. At job A, he makes $8 per hour. And at job B, he makes $9 per hour. We're still just summarizing the information. I think there's some other information they gave us that I just sort of forgot about in the first sentence.
What else?
I could have labeled that on the table right off. Mike works a total of 60 hours per week. Where do you think I'm going to put that 60 on this table?
Underneath the hours worked.
Okay, the number of hours worked. He works a total of 60 hours. And this column right here spells out one equation. What is it? What is this equation? What is this column giving us? If you take the number of hours he worked at job A and add it to the number of hours he worked at job B, that'd better give us 60. So X plus Y is equal to 60. Any questions on my logic there?
Hopefully you see this is sort of similar to the ones we've done before. There is a pattern to these problems.
I should have made a table for that first one,
Well, okay.
you know, because we could have summarized that information with the table on that first one as well, rather than just sort of talking our way through it.
Okay.
Okay, go back. I think there's some more information. What else have they told us in this problem that we haven't taken into account?
There's one number.
If his total pay for 1 week is $501, so he makes $501 1 week. Where do you think I should put that 501?
Pay per hour?
If you add up all the pay he gets, it better be $501.
In a way, per week, that's not too bad, but it's bad that he has to work 60 hours.
Oh yeah, $501 if you were working, less.
40 hours.
60 hours. Oh wow.
You take, now, let's see it. Job A, how much money did he make from job A? You take the price, the pay per hour times the number of hours worked. So 8x is the money he made from job A. Now follow my logic where that 8x comes from. That's all the money he made from job A that week. You tell me how much money he made at job B. $9 per hour times the number of hours, so plus 9y. Here's all the money he made at job A. You add it to all the money he made at job B, and that'd better give us the $501 he made that week. Any questions on my logic? Okay, elimination or substitution. What do y'all want to do? Elimination, yes, okay. I'm going to eliminate x because 8 is smaller than 9. Rather than having to multiply through by a negative 9 up here to eliminate y, I think I'd rather multiply by 8 because it's just a smaller number. And now why am I multiplying by negative 8?
So that you can easily subtract it.
Remember, you have to have the same number but opposite signs. So, negative 8. So that gives us the equation. Distributing through a negative 8, we get a negative 8, negative 8x. What else?
Negative 8y.
Okay. Equals negative 8 times 60 gives us
negative 480.
Negative 480, I agree. And we still have that second equation, 8x plus 9y equals 501. Oh, this is falling out so nicely. Negative 8x plus 8x. That's gone. We've eliminated the x's. What are we going to get here when we combine the y columns? Negative 8y plus 9y. I agree with a 1y. Negative 480 plus 501. Is that giving me a positive 21? So, what was this person's name? Mike worked, notice, why am I putting the 21 here rather than up here? Because it's y. Y is 21. Mike worked 21 hours at job B.
So we can just minus 21 from 60 to get 39 for what he worked at job A.
Right, so it has to add up to 60. What number plus 21 gives you 60? 60 minus 21 gives us 39. Well, that's really annoying. I know it. So he worked 39 hours at job A 21 hours at job B. Any questions there? So 39 hours at job A and 21 hours at job B. Any questions there?
You might look at them and notice they do sort of have the same pattern. The first equation is always x plus y equals a total, right? X plus y equals some total. Even this one, before you didn't write the table per se, x plus y equals a total. 2 times x plus 1 times y equals a total.
You know something? Go back to that problem.
Which one?
Number 15, where I didn't write out a table. I want to show you we could write out a table pretty easily. We have, now let's just go back to that problem first. Read the problem.
Go back to number 15. Okay.
We know that how many 2-point shots did she make and how many free throws did she make?
Tim,
So
I'm going to just hit similar problem.
Oh, I like
and you can
that.
do it with the table.
Yeah,
Okay?
I like that. Okay. I forgot about that. Okay. So we're going to do another problem. This is number 15. Now,
With the table.
a basketball player scored 29 times during one game. She scored a total of 50 points. Wow, she was really good. 2 for each 2-point shot and 1 for each free throw. How many 2-point shots did she make and how many free throws? So this is number 15 once again. And let's switch over. There are two things we don't know. How many 2-point shots she got? 2-point shots. And how many free throws? Those are the two things we don't know, so I'm going to let X and Y be my quantities. I'm just going to say how many rather than quantities. She made X 2-point shots. She made Y free throws. Go on, let's go back and read some more. Okay. Hey, she scored 29 times during one game. She scored 29 times, so if you add the number of 2-point shots to the number of free throws, that would better give the 29 times she scored. They tell us that the 2-point shots are worth 2 points.
This is going to be the point column.
Yeah. Points. The free throws were worth how many points? Only 1 per throw. Go back. Let's read it again. She scored a total of 50 points.
Wow, she was great.
I know. So if you add up that points column, it's going to give a total of 50 points. What are the two equations? We know we need two distinct equations because we have two distinct variables. Okay, X plus Y equals 29, I agree. And then, okay, so 2 times X, that's all the points she got from the 2-point shots, plus 1 times Y, that's how many points she got from the free throw, and that's going to equal 50, I agree. And we used elimination on this, right? The first time we did it. Well,
Stick with elimination.
I'm just going to say I'm going to use elimination again. And what letter do you think I'm going to eliminate, X or Y? Y, because we already have coefficients of 1 there. I'm just going to make this first one a negative 1y by multiplying through by negative 1. So we have a negative 1x minus y equals a negative 29. And we have a 2x plus y equals 50. Adding the two equations together, negative x plus 2x gives me x. What happens to the y's? So we've eliminated those. Negative 29 plus 50 gives me a positive 21. So let's see, answer. X is 21. So she made 21 2-point shots. How many free throws? Remember, she scored how many times? 29. So what would this have to be to add up to 29? 8. I agree. She scored 21 2-point shots. She scored 8 free throws.
Punch that in.
2 points, 21,
2 points,
and 8 free throws. Any questions there?
So I like this table you're making like that.
Oh, I'm glad I thought of it. Okay.
And hopefully you see they sort of follow a pattern.
Yeah, when you look at it through a table, it really does start looking like there's a pattern, okay? So I'm going to stop the video.